Welcome back to video 4. We are rocking and rolling through Unit 1. So we are going to be talking about experiments today. This is going to be a huge portion of the unit, so make sure that you have your experiment notes out and you're ready to get started. Look at all of these learning targets. We've got a lot, but we will get through, I promise. So this will show you that experiments are a huge part of this unit, and you really want to make sure that you're focused and you're paying attention. You're going to see a lot of new vocab in this video, so make sure you are focusing on that as well. Okay, let's get started. So why do we use experiments? Well, we use experiments in psychology to explore cause and effect. Because remember, experiments are the only research method that isolates cause and effect. Everything with correlation, observation, all that stuff, it's great, but it can't tell us if one thing causes the other. Only experiments can. And so research is really going to be the backbone of psychology. And we've got some examples of some famous experiments that we're going to look at throughout the year. You've probably heard of Pavlov and his dogs. And there's going to be some others that we're going to look at as well. Okay, so in an experiment, let's look at some of the things that we'll need and some of the steps that we'll go through. So we always have to have a hypothesis, and that's going to be a testable prediction, which you should already know. So let's take the example of caffeine helps keep high school teachers alert and happy. So we want to test the effects of caffeine on the behavior of high school teachers. And so at this point, you have two variables. You have happiness and you have caffeine. And what do we have to do? We have to create operational definitions for those two variables so other people can replicate this experiment in the future. Now, what did we talk about with happiness? Happiness is really, really hard to define, right? So we are going to have to use something to help us measure happiness. So if you remember from the last video, in an experiment, if we want to try to measure something like happiness or attitudes or beliefs, we have to use a survey. And still, there's some issues with that, but that's our best option. So then if someone is trying to replicate this experiment in the future, they can use that same survey so we can keep everything as clear as possible. We also need to operationally define caffeine, because what does that look like, right? Is that 1 cup of coffee? Is that an espresso? Is that a cup of coffee from Starbucks with 4 pumps of vanilla and something, right? We always need to define both of our variables as clear as possible so people can replicate and get rid of any outside factor that could mess up the results. Okay, so we have our hypothesis, we have the two variables. Now, who is our population? So we said that we want to look at high school teachers. That's our population. So if we were doing this experiment, we could look at high school teachers at Creekview High School. So we've got a large group of people to choose from, over 200 teachers. That's going to be our population. Now, do we test all 200 teachers or 200 plus? No, we don't have time for that, right? So you have to have a sample. So what is your sample? How do you get there? Well, your sample needs to be representative of the population that you are trying to experiment with. So if we were trying to have a representative sample of the whole population of teachers at Creekview, what would that look like? Well, you would think that you would probably need some math teachers, some science teachers, some English history, maybe some fine arts, maybe some coaches. Do you want all the old teachers? Probably not, because there's young, cool ones also. Do you want only the young teachers? No, right? So we've got to figure out how we can get a sample that's representative of the whole population that we're trying to experiment on. So how are we going to do that? Well, let me give you an example that works every single time. And if you've taken AP Stats with Mr. Rooks, he uses this as well. A really good way, always, to get a random sample is putting everyone's name in a hat and then drawing out different names at random to get a representative sample. So, for example, if there's 250 teachers at Creekview, everyone's name goes in the hat, and then say you want your sample size to be around 50, 70, then you need to pull out that many names. And that would give you a good random sample because that's completely random. If you have to do an FRQ over research, which hint, hint, you will because AP Psychology has made that decision, this is always a really good example that you can use in your FRQ of how to get a random sample. Now, there's another type of sample. You can get a stratified sample, which is basically where you take your population, you divide it into relative or relevant subcategories, and then you take your random sample from there. So, for example, maybe you could put all of the teachers in category based on subject, maybe all the science teachers together, all the math teachers together, and then take random samples out of that. Or you could split them up male, female, a new teacher versus an old teacher, something like that. So just make sure you know the difference between random sample and stratified sample. Okay, so we have our key understanding, which I've already reiterated a couple times, but I want to say it one more time. We randomly sample, so the sample is representative of the population. Now, why is that so important? Because researchers want to generalize their findings to apply to the population, right? We can't just have our findings applied to the sample. We want those findings to then be able to apply to the whole population. So again, if you're trying to find how caffeine affects the happiness of teachers, and your sample is only female English teachers, then that's great. But that finding of how caffeine affects female English teachers, you can't then take that and relate it to the population because not all teachers are female English teachers, right? What about female history teachers or male history teachers or male math teachers, right? You have to have a representative sample so then your findings can also be representative of the population. Okay, after you have your random sample, now you get to randomly assign people to two different groups. We're doing a lot of random stuff. So you're going to have two different groups when you do an experiment. You're going to have an experimental group. Those are the people that you're testing. Then you're going to have a control group. And those people are going to continue doing the same thing because you have to be able to compare the experimental group to something, right? So if you, to put people into two different groups, you can do the same thing with the hat, right? You can put everyone's name in a hat and pull one name and say, okay, Susie, you're in the experimental group. Then pull another name out of the hat and say, okay, John, you're in the control group. Or you can have an even number of red and black cards and hand those out randomly. It really doesn't matter, but you want to make sure that out of your random sample, those people are then randomly put into two different groups, the experimental group or the control group. And we do this because we want to minimize differences between the two groups, right? You don't want all males in the experimental group and then all women in the control group. That adds a lot of confounding variables, and then that's not going to give us good findings for the experiment. Okay, another key understanding here. We randomly assign so that the pre-existing differences, so that can be anything, right? Gender, intelligence, temperament, any differences. We randomly assign so the pre-existing differences between the groups does not impact the results of the experiment. So what could those pre-existing differences be? Well, I kind of listed a couple, but if you're looking at this experiment specifically, it could be caffeine tolerance. You don't want all the people who get really jumpy from caffeine in one group and then put everyone who has a tolerance to caffeine in the other. That's not going to be good for you. You don't want to put all the active people in one group and all the unhealthy people in the other, right? You want any kind of difference to be split up pretty evenly in the different groups, because we really want to eliminate confounding variables. And confounding variables are just things that get in the way that can decrease the validity of our results in the experiment. Okay, so like I said, we've got two groups. Experimental group, so those are the people that are going to receive the special treatment. And then you have the control group, and those are the people that aren't going to receive it. So let's look at that using the example that we've been going along with. So group A, these are the people that are actually going to get the caffeine because they're in the experimental group. So let's say we have defined caffeine as 2 cups of regular caffeinated coffee every morning. So group A is going to drink 2 cups of coffee every morning for a month, which that just hurts me in my stomach a little bit, but it's okay. And then you have the control group. You can't just give them no caffeine, because then they're going to know that they're the group with no caffeine. So you have to give them something that tastes like caffeine or looks like caffeine, so they don't realize that they're in the control group. So you can give one group 2 cups of decaf coffee, or you could even go with a group that drinks hot brown coffee flavored water for a month. One thing with the control group, most of the time they just have one group, like there's one experimental group and then one control group, but you can potentially have a couple control groups. So in this experiment, they split the control group into group B and C, but you could also just do like group B or group C. So it doesn't have to be more than one. Okay, so let's look at different variables. So a big part of this unit is going to be identifying the independent variable and the dependent variable. Which one is causing something to happen, or what is the manipulation, and then what variable is being affected by that. So we have our experiment about caffeine and how that affects the happiness levels of teachers. So what is being added in and what is being manipulated to cause an effect? Well, that's going to be the caffeine, right? We're adding in the caffeine. It's being manipulated by the experimenter, so either caffeine or no caffeine, to affect who's being studied. So in this case, it would be the drink. It would be the caffeine. And then you have the dependent variable. So that's what's being affected. So that's the happiness, right? And so, or you could say it's the behavior. But the dependent variable is usually going to be a behavior or a mental process, but it's whatever is being affected. So the type of drink or the caffeine is the independent variable, and then the dependent variable is the behavior, aka the happiness. So it's always going to be like there's only going to be one, like independent variable and dependent variable. So if you were answering an FRQ about this and it asked, what's the independent variable? You would say type of drink. And if it said, what's the dependent variable? You would say behavior. And then you would apply it back to your specific experiment in that you could say caffeine, happiness, alertness, all of that stuff. Okay, another key understanding here, both groups receive the independent variable. The difference is that they receive degrees of that independent variable. So both groups think that they are receiving the independent variable. Just like you saw, the experimental group, they get the caffeine. The control group, they're going to get something that they think is caffeine, so maybe decaf or that brown water. So they aren't So they don't know that they're in the control group. And the people in the control group that get what they think is caffeine or that independent variable, they're actually getting a placebo. So some of us have probably heard this word before, but this is basically like a fake treatment. So why would you have a placebo? Because we want to test the true effects of the independent variable, and sometimes beliefs can alter the behavior. So the placebo in this experiment would be if you picked the decaffeinated coffee or the coffee flavored water, something that the people think they're getting the caffeine, but they really aren't. So an example of this would be, say you have a really bad headache and I give you what you think is Advil, but it's really just a sugar pill. Then you take it, and then 15, 20, 30 minutes later, you're like, oh, my head feels so much better. Well, I didn't give you anything to make your head feel better, but you thought you were taking pain medicine, so then in return, you felt better. That's the placebo effect. So we have the placebo in the experiment to not let the groups know what group they're in. Okay, so we have to control the experiment to avoid bias. So we have a couple different ways to do that. We can do a single blind research study or experiment, and that means it's only the participants are unaware which group they're in. So if we're testing our teachers, the teachers don't know if they're in the experimental group or the control group, but the people giving the experiment, they know. Now, if you don't want to go that route, if you want no one to know, you're going to do a double-blind research or double-blind study. And this is where both the participants and the researchers are unaware which group the participants are in. So the teachers who are the participants and the researchers that are collecting the data don't know which group the participants are in. So think to yourself, which one do you think would be better and why do you think it would be better? Okay, hopefully we can see that the double-blind research is better for controlling biases, but why is that the case? So think about if the researcher knows which teacher is in which group. And say they see Miss Smith coming up to grab her survey for the day to measure her happiness. And I know, or the researcher knows, that Miss Smith doesn't have caffeine. She's in the control group. Well, then I might be like, hi, how are you? Are you feeling tired today? Just go ahead, take a seat, fill out the survey, take your time. Me saying that is adding bias to the situation. I'm almost priming her to give me sluggish behavior or fill out the survey to let me know that she's tired and she has less happiness. So if I or the experimenter doesn't know who's in what group, you can't prime people to behave certain ways, if that makes sense. Okay, and then that will help eliminate some of these confounding variables. So this is any other item that can affect the outcome of the experiment other than the independent variable. We're not talking about that. This is anything else. So for this experiment, what could some confounding variables be? So you still have some caffeine in the decaf coffee, and maybe someone in that group still gets real amped on decaf coffee. Well, that might throw you off a little bit. Whether someone is a regular coffee drinker and they're used to it versus if they don't, then that can have an effect. Amount of sleep. I don't care how much coffee I have some days, I'm still going to be tired if I don't sleep. So in your head, think about anything that is outside of the experiment that could impact the experiment. So how do we get rid of these confounding variables? That is why we have to control our experiment, and that's why we randomly assign people into different groups. Because like I said before, you don't want all the active people in one group and all of the people who drink coffee all the time in the other group, right? You want people randomly assigned, and you want to control the experiment as much as possible, because if you have all these different variables that are in your experiment, your results aren't valid anymore, and then it's a waste of time, right? So you want your experiment to be as controlled as possible, and we want to make sure that any confounding variables are taken care of. We don't want these. Confounding variables are not good. We don't want these. So that is it for this video. I hope you enjoyed it. This is a very, 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 very important video. Hopefully you took your notes. I would personally go back in my notes and maybe highlight some of those key terms so I know the main vocab words in this unit. Make sure you do your practice for this as well. And I will see you soon. We're almost done with Unit 1.